Hi, my name is Samantha Brewer and I, along with my teammate Brian Fredrickson, will detail what we completed for Sprint 4 of our project Cyber1 Code Version. Cyber1 Code Version is a research project meant to help develop an automated program for generating semantic clones of a given Python source code file, with the goal being to help improve signature-based intrusion detection systems in cybersecurity. Brian and I both researched different obfuscation techniques for this project, and we'll try to implement it into the program as we go, so the clones are as different as possible visually. For Sprint 4, we spent most of our time looking into other potential data types to represent the source code in, as well as develop new obfuscation techniques such as swapping out loops or translating function and variable names to other foreign languages. For this sprint, our team spent most of our time looking into alternative data types to represent the code in. Code property graphs and later code flow graphs were explored because they could offer different ways to manipulate the code. Ultimately, neither panned out due to limited support in Python for the CFGs and the inability to edit sections of the graph and export as functional source code for CPGs. After a meeting with our mentor, we decided to stick with concrete syntax trees and build on what we developed last semester. Brian began working on swapping loop types, such as for loops into while loops where the amount of runs is the same, while I worked on removing the function variable renaming from random word banks in AI. Due to the late pivot back to concrete syntax trees, we were unable to finalize these features, but a lot has been set up for our next sprint. For Sprint 4, as mentioned earlier, we weren't able to fully work on what we planned to due to the research into other graph types that didn't fully pan out. So when we moved back to concrete syntax trees, Brian and I decided to a different obfuscation technique to focus on. Brian will go into what he went through with loops later, but I will go through what I worked on, which was improving our pre-existing variable and function renamer. The way we left it originally at the end of last semester was that it would pull from random word banks of either colors or animals that were predefined earlier if the API request to translate it by putting in the entire function or variable rename into Gemini ran out of tokens. So to remove that dependency on an external AI where we would need to pay for tokens and so on, and also make it more plausible with these variable renamings, I looked into parsing variable and function names, changing abbreviations, and then at the end of it, hopefully being able to translate these variable and function names into other foreign languages. So as I just said, first, it will go through and split up the word based on common naming conventions. So once you run this function, it'll basically split it into a list of each individual chunk, broken up by either capital letters, preserving that letter, underscores, or dashes. And then after that, I created a word bank from a outside resource that lists common coding abbreviations to cut down on how many words you would need for variables. So through here, it creates a dictionary where it finds these specific variable or function abbreviations and then converts them to the original full word and then swaps them out. And so when you run these two, which were finished, the translation software ran into a few hiccups, I'll go into it later. When you run it, you can see that it breaks it up based on all these different sorts of naming conventions. So camel case gets broken up. It cannot parse if it's all flat case or uppercase because that would require a more involved parser actually working with an English dictionary. But you can see down here how cur-val becomes current and value because it removes those abbreviations and replaces them with the original terms. From here, what we planned on having it do is go through, pick a random foreign language, and take these words and try to translate them and then squish the entire variable or function list name back together into a single string following a random naming convention so that it looks as different as possible while still meaning the same thing preferably. But with that, we ran into a couple issues. As with the API issues earlier, most of the language translation software works on an online API that you query, and so we ran out of tokens. And when we made the jump to switch to an offline translation thing, the main problem with that is that all these different foreign language packages would have to be installed, and because of the way Colab works, you would have to reinstall all of them every time you did a runtime for this because it does not save progress, and that got very time consuming. So what I'm planning is to move it into the GUI space and developing a GUI that can run solely on the computer so that we would only need to install all these packages once. because a GUI was already something we were going to work for, but now the translation has been put on the back burner so we can prioritize a GUI and know it works on the software and the computer, so that then we can install the translation programs and continue with what this obfuscation technique was planned for.
Hello, everyone. This is Brian, and I'm going to be showcasing my contributions to Sprint 4. So one of the features that I started implementing was the logic renamer. So in previous sprints, we just had the variable and function renamer to increase obfuscation and to change up the words of variables and functions. Sam implemented a variable and function parser for a more efficient way instead of using the Gemini API. And I focused on logic renaming, such as changing code logic, such as while loops to for loops, and vice versa. In future sprints, we're going to be implementing if statements, kind of playing around with how we can change those to look different and increase the obfuscation. So for this sprint, I was able to deal with while loop to for loop conversion, specifically for less than and greater than operations. The main challenge with this one is just tackling all the edge cases, and for testing those, you kind of just have to evaluate different code snippets and play around with different expression combinations such as this one. So as you can see here, this is the logic renamer subclass. It's a different derived class than the CST transformer class that contains methods such as the less than handler, the greater than handler, and the leave while. So this gets invoked whenever a node in the CST is a while loop, and it converts it to for loops. I'm going to go over the results here. So this is the output of what another Python test file would look like if you were to put the test.py through it. So this is the initial file. So you have while conditions, and then it spits out for loops, and it functionally runs the same, but it appears different. So this is the obfuscation section of this. And like I said, the testing is mostly just looking for different edge cases and covering those.
The Kanban board reflects the entire sprint generally. In the done column, you can see the issues to research code property and flow graphs are closed, since we have decided to stop researching them and stick with concrete syntax trees. For the in progress section, you can see the two different obfuscation techniques Brian and I were able to work on with the time left in the sprint, where I was looking into translating function and variable names in a realistic way, and Brian was working on swapping loop types to further obfuscate the logic of the code. In the icebox, you can see the GUI issues that are still open. Next sprint, we will begin work on a rudimentary GUI with tkinter to address the issues I stated earlier about Google Colab and offline translation libraries. Through this, Brian will likely be working on new obfuscation techniques while I work primarily on the GUI with tkinter, so that when the program GUI is finally finished, we can quickly bring in all those other obfuscation techniques so that we don't have a fancy GUI with only the actual program that we developed last semester. Our meeting of minutes follows the general path Sprint 4 took in terms of development. Our first meeting with our mentor, Tashi Stierwalt, was mostly to check in and make sure code property graphs were what we wanted to look into. In this meeting, we went through what we wanted to see in CPGs, see what they could do for our program, and if it was even viable. And as you can see in our next minute of meetings write-up, it didn't exactly pan out. We found that code property graphs were not viable due to its immutability, and code flow graphs were also looked into between the previous meeting and this one, but did not present enough benefits to justify trying to refactor the pipeline to fit it. Ultimately, we decided to stick with concrete syntax trees and work on creating more obfuscation techniques, as addressed earlier with our function and variable translator and the swapping of loops.
So regarding the Sprint 4 report, we're going to talk about what's new for the user-facing. So variable and function token parsing. So that's the section that Sam worked on. I worked on the logic obfuscation techniques such as while to for loops. So the work summary. Since this project or tool is supposed to be kind of used by the users and developers, kind of serve the same purpose here. They get to interact directly with the different changes that are made to the source code. So these kind of serve the same purpose: variable and function renaming, tokenization, and then changing the probability of the obfuscation changes to be made. So some of the unfinished work. We have the GUI components to work on. I think that's the biggest priority that we haven't got to. Kind of put that on the back burner, but that will be something that we'll be integrating within the next sprint. So as far as we know, the token parser for the function and variable renamer, it's pretty hefty library, and we're running this in a collab, so it takes a lot of time. It takes a lot of time to install for each runtime that we invoke. So we're going to find a more efficient way to do that, and then we're going to keep implementing the obfuscation techniques for the logic renaming. So here are some of the completed user stories. So we first started out by exploring code property graphs and research and control flow graphs, but the existing Python libraries don't really support functionality for this, and everything that we can do in those libraries can be done through a CST library. Then I'll go over the incomplete user stories. So the UI, of course, and then the GUI. That's this kind of related here. Just implementing a base interface more than the command line for the clients to interact with. Translate variable function names. So that's continuing to develop how the function and variable names are broken up, and what other things we can do with them, such as the naming conventions like camel case, snake case, etc. And then the logic obfuscation. So exploring different edge cases to expand on. And here's what went well. The team did a great job at distributing tasks for the current sprint. I feel like that's kind of the same for every sprint. We'd like to improve. We'd like to improve our progress on the user interface as described above. And for the changes for next sprint, we'll hopefully have a framework that we can show you of how the user will interact, and an actual visual representation of what we have for the command line, and more logic obfuscation techniques, as well as the functionality of the function and variable parsing. So I'm going to be briefly going over the achievements and the challenges from the sprint. A lot of the big achievements came from continuing to implement the code obfuscation, such as the logic renamer. Sam did a great job at implementing the function and variable renamer to replace kind of the Gemini feature, which takes a lot of tokens and increases the time complexity of our program. So continuing to work on that was massive for the sprint. Some of the challenges that we experienced for the sprint was kind of drifting away from our initial plan of using code property graphs and control flow graphs, and utilizing the same CST libraries that we had. So the solution to that, we explored different ways that we could modify code using the current syntax tree, the context syntax tree approach, and I feel like the team did a good job at adapting to that. And the progress from Sprint 4, I mean, of course, the logic renaming part, as opposed to just function and variable renaming, and then working on different methods to extract the different attributes of code syntax, and translating it based on the language. So like camel case and snake case, and different methods of that. So I'm going to dive into the next steps in the sprint retrospective. Some of the upcoming tasks that our team plans to work on is the graphical user interface features. So the end users and clients have a more creative way of interacting than just a command line. So I feel like the team did a good job at kind of adapting to staying away from the enhanced graphs, code property graphs, and the control flow graphs, and just focus on the CST approach. In the future sprints, we're going to keep implementing the current CST methods that we have and expanding on those. Our client also agreed that the Python libraries that it provides for those more enhanced graphs are as open as other methods. So he decided that we should just stick with the CST and see what we could expand upon that. So those are kind of the next steps in the sprint retrospective. So to wrap it up, the things discussed in this sprint 4 video was we introduced the changes made, outlined some objectives, defined some of the features, and demonstrated those features. We took a look at the Kanban overview and the team contributions. We displayed the meeting of minutes to how our client meetings were going. We went over the documentation report of our Sprint 4. We also talked about sprint achievements and challenges, as well as the next steps and we reflected on the sprint of what the team did well, and took a look at what the client observed and took his advice for what to continue for the next sprint. So, in summary, we just recapped all of the major changes in Sprint 4. We want to thank our client, Tashi, for paving a good way for the future sprints and giving us a clear outline of what is expected. And thank you to the viewers for taking a look at this Sprint 4 recap. Thank you.